Are the slides visible, everyone?
Yes, Professor.
Okay, thank you. So let's start the third method under the time series, which is called exponential smoothing. This is a pretty common approach in industries. This is very, very famous and common. So this is used when the demand has no observable trends or seasonality. So when you have so many fluctuations, probably this method is not appropriate. It reacts strongly to recent changes in demand. So it really looks how much recent demand has been changed, and it counts only the last. It only counts the last period in order to calculations. Requires minimum data for the current method and a weighting factor. So that's something good. And the reason that it is very popular is that it uses minimum data. Okay. So I will show you that it only needs the actual demand of the past period and the forecast in the past period. That's it. Only two data points. And it always uses a fixed weighted factor, which is which we call it as alpha. And alpha and 1 minus alpha is something that is between 0 and 1. So in this case is if alpha is 0.7, okay, 1 minus alpha will be 0.3. So in other words, alpha determines how important is the actual versus forecast. So when I'm calculating the demand or the forecast demand for next period, I am telling, um, I am using the calculation using this logic that put 70% importance for the actual data and put 30% importance for forecast data. Okay, so that's how it is translated. Okay, this is the formula that is going to help us in order to calculate demand for next periods. Okay, one example, a firm uses simple exponential smoothing with alpha equal to 0.1. So when alpha is equal to 0.1, uh, the weight is put for recent, the actual data or the forecast of data?
The actual data.
I mean, which one has the highest weight, the actual data or?
The actual data has the highest weight.
Forecasted data.
The forecast data.
The forecast data.
Forecast data has the highest weight, yeah. So when alpha is 0.1, so it means that alpha here is 0.1 and the forecast has 0.9. So it means that I will put more weights on the forecast rather than the actual data, correct? So with alpha equal to 0.1 to forecast the demand, the forecast for the week of January 1st, so which means the first period, was 500 units, where the actual demand, so forecast of the first period is equal to how much? 500. And the actual demand of the first period is how much? The actual demand is
450.
450. Okay. So based on the formula, if I want to calculate the forecast for the second week, which will be F2, so what is the formula? So 0.1 multiply, how much is the actual demand?
450.
450 plus 1 minus 0.1, which is 0.9, multiply, how much is the actual, the forecast demand in past period? 500.
500.
Perfect. And then you are able to calculate that and it will be 495. Okay, 495. Okay, some of you would say this formula is different than this formula, correct? Or this formula, doesn't matter. So which one we should use? Then I'm going to tell you both of them are fine. So if I just multiply alpha to this bracket and then simplify it, I will get to this slide, okay, this formula. So both of them are fine. Use whatever you like, whatever you prefer, and it's easier for you to use, okay? So both formulas are true and correct for us. You can use any of them. Any questions from this example? Is it clear for everyone? Okay. Let's solve another example. The following data shows the monthly sales of a particular product in tons. So, how many periods are here?
4.
4 periods. And what you see here is the actual demand or forecast demand.
The actual.
Actual.
This is actual demand, correct. And then it's asking you, I have two options. Option number 1 is I assume alpha is equal to 0.5. In other words, assign equal weights for actual and
The forecast.
Forecast.
forecast data. Perfect. Or use the second method, which alpha is equal to 0.1. So assign more weights for
The actual value.
Actual data.
assign more weights for
Sorry, the forecast one.
forecast one. We just reviewed that. So when alpha is 0.1, you are assigning more weights for what? Actual or for forecast?
Forecast.
Forecast, because forecast is 0.9, correct? So you have the freedom to choose alpha equal to 0.5 or 0.1. And it is asking you, I really don't care which one you use. What I really care is that I need to forecast the demand for the 5th period, and I want it to be the most accurate one. So what do you suggest in this case? What should I do? So I'm going to repeat again. I have the actual data for 4 periods. I have the freedom to select the first method, which alpha is 0.5, second method alpha is 0.1. I am asked to calculate how much is the forecast for the 5th period. And another important factor, the demand for the 5th period, the forecasted demand should be the most accurate one. So what should I do?
Assign 50%.
You assign very little alpha to the forecast.
How did you get to that?
Because because over the past 3 periods, which is the second, third, and fourth month, the differences between them are not so huge. Therefore, you can rely on that. They do not have wide margins that you may think that they were
Okay.
random. They are following a certain trend.
Okay. So what if I have 400 data points? So how do you calculate that? So here it's simple. Yeah, it's 4. What if I have 400? So what do you do in that case? So any other answers? What should we do?
Assign 50-50.
50-50. Okay. Any other answer? Thank you. Any other answers? Okay. So we just finished learning about different methods that measure errors, yeah? So don't you want to use them?
Yeah, you use the math process to find it on the.
Exactly. So you will calculate the forecast for the fifth method one time for 0.5 and one time for 0.1. Then you calculate the MAD value for them. Okay. Whatever has the lowest MAD value, you will decide either 0.5 or 0.1. Okay. So in this case, as you can see, this is the actual demand that is given to me. I don't know how much is the actual demand for the fifth period. That's why I put a question mark here. Then I have two more sections. So the next two columns are calculating for alpha equal to 0.1, and the next two columns are calculating the forecast for alpha equal to 0.5. Okay, and then can I calculate the forecast for the first period? No. And can I calculate the forecast for the second period? Still no. But be careful. This part is absolutely important. Many people do mistake in this stage. You need to make an assumption. Okay, make an assumption. What is that assumption? The forecast of the second period is exactly the same as actual of the first period. Okay, because if I just give you the actual demand, you don't have any forecast. How can you calculate that? There is no way to do that. The only way that you can proceed is to have an assumption. What is that assumption? The actual or the forecast of the second period is the same as the actual of the first period. Now you are able to calculate and go ahead with the calculations. So what is the first period that I can actually start using the formulas? These formulas. What is the first period?
The second period.
No. The second period I already have. I already have the actual for the second period and the forecast for the second period. Yeah. So what is the first period that I can use the formula? Exactly.
Okay.
That's the third period. That is the first period that I can start using these formulas. Correct? Because that's the first period that I have access to past data, either actual data or forecast data. So F3 is the first thing that I can calculate. Okay. And I had one assumption, as I told you before. What was that assumption? F2 is equal to
D1.
Perfect. Perfect. So this is a very important assumption. So that's why I don't need to calculate F2. This is already assumed. Okay. This is already assumed to be the same as the actual here. That's why I start from period number 3. Okay, I do calculate, I put the numbers, I calculate everything, then I calculate the mean absolute deviation. If I divide it, so how many periods I have? Divided by, how many numbers I have here?
3.
3. And the same 3 numbers I have there. So this is divided by 3. So which one has the lowest error?
0.5.
0.5.
0.5 has less error. So which method you prefer to use in order to forecast the demand for the fifth period? Alpha equal to?
Alpha is 0.5.
0.5. So just use the formula and calculate the demand and the forecast for the fifth period. Okay? Just put the numbers. So what is the formula for that? The formula for that is F5, which is the forecast for the fifth period. Okay, it's written here. Just put it there, and then you will have the the forecast data for the 5th period. Okay, is it clear for everyone? Any questions?
No, sir.
Okay. So let's go to the next method. This method is called adjusted exponential smoothing. So there is one extra component which is called adjusted. Okay. If I go back here, do you remember it says used when demand has no observable trend or seasonality. So in other words, demand is very smooth. It's not very fluctuated. So what if the demand is very fluctuated? What should we do? In that case, I have to use adjusted exponential smoothing. Okay, adjusted exponential smoothing. So how does that method works? I'm not going to go deep in that because that's a little bit complicated, and I have provided a video for that on the course, on the Moodle page of the course. Please watch that. I'm going to skip that for now. But the idea is that besides forecasting, you should also consider a trend for that, okay? A trend for that. And then you apply it and calculate that. So the idea is exactly the same as the previous method. We just put an extra component of the trend to count for fluctuations. Okay, so let's move on. So you don't need to we don't need to spend time for that method. The next method that we want to learn, which is um, the trend projection, is a very important and interesting method. We want to learn a little bit more about that. This technique fits a trend line to a series of historical data points and then projects the line into the future. Okay, so in other words, if I have some random data over the time, it says, okay, it's really tough for me to understand how much is the demand. So here you have time and here you have demand, correct? So it's asking you how much should be the trend, how much be the real demand. And the answer is don't worry about that if they are very scattered. Just predict a line that fits there, and then you are able to find the equation of this line. After you find the equation of this line, you are able to put data of time in that equation, and then you can easily find the demand based on the time that you put in the equation. For example, if you are looking for demand at this certain point, look at what is the time. Let's say this is year number 10. And then from there, you are able to find how much is the demand for year number 10. Okay. I know it's a little bit difficult to understand it right away, but the idea is very simple. It's just using the math that you have learned in elementary school or in high school. That's very easy. So what is the idea? So when you have a um, graph like this, and it goes like this. So any line we can use mathematics to show any line. And if you remember, if I want to draw the equation of this line, it can be written as y is equal to a plus bx. Okay, so a is the intercept. Okay, so this is the intercept, which is the difference here. B is the slope. Okay, so if this is the slope of that, so b will be determined here, and then x is here, which is in this case time. Okay, so using these factors, you can easily calculate y, which is the demand for next season. Okay, let's solve one example, and using this example, we will learn how to apply it. So let's read the example. The dean of a private college wishes to forecast the enrollment of the next fall term. Data representing the fall enrollment for the past 10 years is given below. What is the forecast for enrollment in year 11? Okay, how much is the forecast for year 11? So I have the data for 10 years. I don't know how much will be the enrollment of the year number 11, which is the next fall. Okay, so I'm asked to use trend projection in order to find how much is the demand in that period. So what should I do? So all I'm going to
You
do
find
is,
your
yes, all I'm going to do is finding the equation of the line. Okay, equation of this line. After I found the equation of this line, I just put instead of x, what should I put instead of x?
11.
11. You put 11, and then you can easily find how much is the demand related to year number 11. Okay, so everybody, this slide is absolutely important. Please pay attention, okay? So make sure you are focused and you understand this perfectly. So what was the formula? The formula was y equal to a plus
BX.
bx. Okay. I already know that x will be 11, correct? Because I'm predicting for period number 11. But do I know b and a? Not yet. Okay. So my focus should be finding a and b. Because if I know a and b, and I already know x, I can easily find how much is the number of enrollment in year number 11. Okay. The good point is that all of these formulas are available and I can easily use it. So the first step is finding B. Okay, finding B is the first step. So B is calculated as this fraction. Okay, but before I want to explain that, I need to mention you need to add some columns to your raw data. What are those columns? So what's the name of this column, which is here? Is it X or Y?
X.
This is X, that's right. So this is X. What about the number of enrollment? This is X or Y?
Y.
This is Y. This is clear. This is Y. Okay, I need to expand this table a little bit. Then what are the new columns that I have to add? There are some columns that I have to add. The next column that I need to add is X multiply Y. So I call it X multiply Y. So in this case, it will be 1 multiply 700, which is 700. Okay. 2 multiply 724, which will be 1448. Okay. 3 multiply 720. So you will write all the numbers. So x multiply 1, x multiply y. And then what is the next column that I have to create? X squared. Okay. So how much is x squared here?
1, 4, 9, 16, 25,
Up to, yes,
36,
36,
14.
49.
that's right, up to the very last. Okay. So this is the next thing that I have to calculate. And again, this is elementary school mathematics. What I am going to need as the next step, I need to calculate some other factors as well. The next factors are the averages. Okay. We normally show averages as bar. So X bar means the average of X's in this column. Okay. And then finding how much is the average of numbers from 1 to 10. If we calculate that, so the summation of them will be 55. So it will be 55
5.5.
divided by 10. So it will be 5.5. How much is the Y average or Y bar? So you need to calculate how much is the summation of all of these numbers, okay? And then divide it by 10, okay? So if I go back to this slide, the summation of all y's is 7,407. If you divide it by 10, it will be 740.7. Okay? Then the same thing, you need to calculate the summation of all x multiply y's and the summation of x squared. And then you need to calculate the average of them as well, which is simply dividing them by the number of years. So this should be, so if I want to calculate x squared bar, so it will be how much? 3.8.5. Okay, the same as here. So if I want the average, so it will be this number divided by 10.
4135 by 0.8.
That's right. So after I did these calculations, so the first step is calculating this table. What is the second step? Second step is calculating the value of b. Okay, so in order to calculate b, I need something that is written here. So how much is the summation of x multiply y? This part. How much is that?
41358.
4135.
I already have it. Perfect. How much is n? So how many periods I have right now?
10.
10.
10. I just put 10 here. How much is x bar? X bar.
55.
X bar.
Sorry, 5.5.
5.5.
5.5. Perfect. How much is y bar?
740.7.
That's right. So this number divided by 10, which is 740.7. Okay. So done with numerator. What about denominator? So how much is the summation of x squared?
385.
Okay. So be careful here because that's here, yeah. So this is the summation of them. And then I have n, which is again 10,
10.
and then x bar squared. So x bar
38.5.
squared. So 5.5. Be careful about that. That's the important things. So x bar squared. So how much is the x bar? 5.5. Then s squared. So it will be 30.25. Okay. And then just replace the numbers in this fraction, then you will get 7.5. So this is the slope of the line. This was the step number. Yes.
Professor, would you please reply how can I get 30.25?
Sure, sure. So that is coming from here. Sorry. So what is the formula? X bar x squared. Okay. So how much is x bar?
It's 5.5.
So if you square it, it will be 30.25. Okay.
Okay, thank you.
There is a chance that the students do mistake. And what is that mistake? The mistake. Okay. Make sure you are muted if you are not talking. Okay. So this is the second step. I could calculate B, which is the slope. The third step is calculating A, okay, which is the intercept. That's pretty simple. So how can I do that? I have the y bar value. How much is the y bar? How much is the y bar? This number divided by 10.
740.7.
Exactly. Do I have B?
Yes.
Yes, I already calculated at the end of step number 2. Do I have X bar?
Yes.
Yes, I have it. Okay,
Yes.
that's the number that I got it. So this way I can calculate A as well. So I could calculate A, I could calculate B, and I know the value of X. Can I calculate Y? Easily I can do that. So that's why I just need to replace the numbers. So Y for year number 11 is equal to A plus B
B,
X.
X.
I have B, I have A, and I know X is 11. Okay, I can easily find the number of enrolled students in year number 11. Okay, clear for everyone? Any questions or any doubts?
Yes, Prof. I think the equation for B, the second part of the summation, the numerator is confusing. N X Y bar.
Yeah, that's
Uh,
why I explained it here. Yeah,
yeah, it has to be separated so that
yeah, yeah, that's right. So that's why I need to put it in brackets. So you need to first calculate X bar and then do a square it. Okay, there is one example. Please solve it. The idea is that I have the demand for 12 months. So I want to calculate the demand for month number 13. Here I have an assumption that demand is a function of time. So I'm using time series. Then I just need to replace all of these fractions, all the equations, and I can easily calculate it. So please do it one time by yourself and then compare it. And very important note here, this chapter is totally different in nature than the other chapters. Other chapters, if you just read the slides, that's totally fine. But if you use the same method for this chapter, you will gonna fail this course. Okay? You will fail this course. Very simple. So what should you do? Please take a piece of paper and a pen, solve the examples and the sample solutions that I have provided on the Moodle page, try to solve them, and then compare the solution that you got with the solution that I have provided. Okay, this is absolutely important. If you don't do that, there is no chance that you pass this course. Okay, there is no chance. So do that, do more practice, and make sure that um, you can do and you can solve more examples. Okay, so end of that method. There is another important topic that we need to cover today, and that's trend projection. So trend projection is another important thing that we need to consider. This is applicable when we have seasonal factors affected to your demand. Okay, so the same example I have provided before. Do people purchase warm jackets equally in summer, winter, fall, and spring, or they have different number of sales in each season?
different number of sales.
Different number of sales, okay? So if I give you that in total, we sell 1,000 jackets per year, can you divide it to different seasons? You can equally divide it, and then it will be 1,000 divided by 4, correct? It will be 1,000, which is the total demand per year, divided by 4. So how much it will be? 250. But do you believe this is the correct number of forecast for each season?
No, sir.
No.
No, this is not correct. So what should I do to make sure that, demand is accurately divided for seasons? So there are two methods that you can use, okay? And I'm going to explain them here. The first method is calculating the seasonal factor. Seasonal factor is calculated as the total calculated as demand per certain season divided by the demand of different seasons. For example, So S, or seasonal factor of season number 1, let's consider this is a spring, okay? This is a spring. So it's like demand of spring divided by demand of the entire year, yeah? So which is demand of spring plus demand of summer plus demand of fall plus demand of winter. So this is going to give me a fraction, okay? So I can calculate it for S1, S2, S3, S3 and S4, okay? So at the end, I'm going to get, this will be 10%, this will be another 10%, this will be 0.6, and this will be 0.2, okay? So if I have 1,000, jackets as the entire sold items, entire jackets per year. So if I know these fractions, I can easily multiply it because the summation of all of them is equal to 1. So I can multiply it to this number and I can tell you how much is the demand in a spring. So can you let me know how much is the demand in a spring? So demand of a spring, how much it will be? It will be 1,000 multiply. How much is the?
100.
0.1.
Okay, so I'm gonna sell 100 jackets in summer.
Yes.
What about demand in summer? So the same numbers, yeah?
Yes.
Because we have the same fractions, so it will be 100. What about fall? Demand of fall. So the entire demand per year multiplied to fraction of seasonal factor, so it will be 600. So I'm going to sell 600 jackets in fall. The same for winter. So I'm going to sell 200 jackets in winter. So that's all the idea related to trend, to the seasonal factors, okay? Seasonal factors. So there is another example here. As you can see, I have 4 seasons. I have the total of all of them, so 1,000, 1,000. So 1,000 total items sold. I normally sell 200 in spring, 350 in summer, blah blah, up to winter. Okay, so one idea is to just divide it by 1,000, which is the easiest way. So if you divide it by 1,000, how much will be the seasonal factor for spring? 0.2.
0.2.
Exactly. And how much will be for summer? 0.35.
0.35.
Exactly. And then the other one is
0.3.
0.3, and the final winter
0.15.
1.5. Okay. So if I tell you that based on trend projection, I have found that next year I'm going to sell 1,200 jackets. Can you tell me how much I will sell in spring? So what should I do?
You
You
multiply.
multiply it by the seasonal factor.
Exactly. So it will be 1,200 multiply
0.2.
0.2. Perfect. And
2.35.
then this one multiplied to 0.35 up to the very last one. Okay. This is in summary what trend projection means. Forget about average sold, forget about seasonal factor using another method. Just use the method that I told you, okay? Calculate how much is the summation of all demands and then divide the demand of individual seasons by the total demand, then you will get a fraction. This is called the seasonal factor. So if this is 1,200, you multiply to 1,200. If it is 2,000, then you will multiply to 2,000. So seasonal factor will be multiplied to 2,000. Is it clear for everyone?
Yes,
Is it?
sir.
Yes, sir.
Is
Prof, but even if they use the method that was on the slide before, average sold, and you still arrive at the same answer.
Exactly, exactly. But because that method is a little bit complicated, so that's why I skip explaining that. But if you read the slides, you will fully understand that that is also give you the same results. Okay, thank you for asking. So there is one example. ABC company is a Northwest manufacturer, blah, blah. They make women's shoes. Demand is highly seasonal for women's shoes. The company has experienced difficulty in making accurate forecasts. The following table gives the quantity of the shoes probably sold by quarters in the last 3 years. So I have the data for last 3 years, okay, from 1998 to 2000. Then I am asked, first of all, to calculate how much is the demand for 2001, okay? And so that's the first part of this question. In the second part of this question is asking you how much is the distribution of demand per different seasons. So question, can you let me know how can I calculate the demand for year 2001? I'm going to use
Forecasting for that.
exactly. I'm going to use trend projection. Okay. So all I'm going to need is x, y, x multiply y, and x squared. Okay. So if I put x, y, x multiply y, and x squared, so it will should be very easy to calculate. So how many periods I have? 1, 2, and 3, which is 1998, 1999, and 2000. Correct? And what I am looking for is year number 4, which is 2001. Correct? And how much is the demand for year number 1, which is 1998? I have to add all of them together and write the summation here. Correct? This will be the total demand per that year. Correct? So I'm going to write it here. How much is the summation of all demand per different seasons for year 1999? I'm going to write it down here. How much is the summation of all demands per different seasons for year 2000? I will write it down here. Okay? Then I'm able to calculate x multiply y. Then I'm able to calculate x squared. Then I'm able to calculate x bar, y bar, and then x bar squared, y bar, whatever. Then I'm able to calculate a, b, and because x is equal to 4, I can easily calculate y for year 2000. After I calculated the y value for year 2000, is it finished? No. Still, I have to proceed. I have to divide it to different seasons. How can I do that? Any idea?
You find the ratio of the each season against the total.
Exactly. So all I'm going to do is find how much is the average of these numbers. I'm going to write it down here, or summation is also fine. How much is the summation of these numbers? I'm going to write it down here. How much is the summation of these numbers? So these are the summation of all shoes sold in winter, in summer, whatever. Okay. Then I need to divide it by the total shoes sold in the entire past 3 years. Okay, so that's the large number. So I'm going to divide it by that. The summation of all shoes sold in past 3 years, that will be reflected here. Then I'm able to find the seasonal factor by dividing the total shoes sold in past 3 years in summer, in winter, in fall, in spring, and then I get a fraction. All I should do is multiplying that fraction to seasonal factor, correct? These are all the steps that I told you. So all I need is to calculate all the demands, okay? X, Y, X multiply Y, all of them. Then you will calculate the total demand. So if you calculate the total demand, it will be 1466, okay? So that's the total demand for 2001. If you know the total demand for 2001, so you can easily multiply it by the seasonal factor, which you know how to calculate it. So if this is the average demand here, you need to divide it by the average of the entire, or you can just add all of them together and then you get to the same results. Okay, so do it by yourself and compare the results here, and then you will find out how much is the demand per season. As you can see, yeah, as you can see for the first quarter, this is the demand for the second quarter. This is the demand for third. This is the demand. So this slide is using the most difficult method, which is, I told you, try to skip it. This method is using this method. You please try to use the simple method that I told you, this one. Okay, try to use this method. This is much easier to proceed. Okay, any questions?
Professor, I have a question. So maybe I
Sure.
have missed. Um, uh, the demand forecast for each quarter in year 4 is as follows. We got that 366.5, right? In the next slide.
Oh yeah, yeah. Here, yes.
Yes. Professor, how can we get in first quarter 360.5 multiply 1.883? Where I can find 1.883 here? Those numbers? Yes.
These are the difficult method that I told you. As you can see, but there is a
Okay.
simpler method, as I already explained that. What is the simplest method? How much is the summation of these numbers?
You
Okay.
use the
You,
totals.
yes. How much is the summation of these numbers? Then write down. How much is the summation of these numbers? Then write it down. You don't need all of these tables. Okay. Just write down the summation of the numbers. Okay. Then divide this column by which number? The summation of all of them. The total shoes that you have sold in all seasons, all 3 years. Okay. So let's call that call it a fraction here. Whatever you get by dividing this number 1, by this large number, which is number 5. So 1 divided by 5 is going to give you seasonal factor for the first season. 2, which is this number, divided by 5 is going to give you the seasonal factor for the second season, up to the very last one. Okay. So this way you're able to find the seasonal factors for 4 seasons. And what's the next step? We should multiply
You
it.
multiply by the demand in
So how much is the
2001.
exactly? How much is the total demand in year 2001? This is the total demand. So
1466.
you need to multiply the total demand of year by the fraction of demand that you find it out in past 3 years. Okay. So this way you are able to calculate it. Is it clear, or you want me to explain it again?
Okay, Professor. Clear, Professor.
Okay, great. So again, try to solve one example by yourself, then you will find it out. Okay, so time series methods are done. I just need 2 more minutes to finish it, and then we are done. So causal methods are the same as trend projection. The only difference is that here we have X, which could be number of students, blah, blah, blah. And in trend projection, it was only time. But the formula is the same, everything is the same, okay? So there is nothing new. There is another example you can see that is using the same things. So x, y, x squared, y squared. So these are exactly what we used to have before. The only difference is that here also I have provided the regression formula. So you calculate R, which is the correlation rate. So correlation rate, which is a little bit complicated formula, and I don't expect you to calculate that, is going to give you us a sense of how much X and Y are related. X and Y are related. How much the amount of food that I bring to the campus is related to the number of students. Okay. So in this case, if it is 0.997, which is a number close to 1, so it means that X and Y are very related. If R is a number close to 0, what does it mean? It means that X and Y are not related at all. Okay, they are not related at all to each other. Okay, so that's the meaning of correlation between X and Y. And again, because you have read that in your statistics, I don't need to open it up anymore. So R is a number between minus 1 and 1. So if it is minus 1 and 1, and then I have 0. 0 means there is no relationship between X and Y. 1 means there is a strong relationship between X and Y. So this is a strong relationship. Here there is no relationship. And if it is minus 1, what does it mean? There is a reverse
they have an
relationship.
opposite relationship.
Exactly. So by increasing the number of students on campus, the number of foods will be reduced, which doesn't make sense in this case. But so by increasing the inflation rate, the amount of products purchased by people will be reduced. Okay, so that's another example. And the very advanced idea is multiple regression, which means that there is not only one factor. For example, time, there are multiple factors. We don't need to learn it, and I will not ask in the exam, but real life problems such as machine learning problems or regression problems, they're all problems like this. So we have multiple factors contributing to your demand in real life, but we're not going to cover that. It's not important. And the very last method that I told you is qualitative methods. So qualitative methods are useful when we don't have data. So in those cases, we are going to use qualitative data. So we are going to ask a group of people that what's their opinion, how much will be the demand in the future. So people who are experts. For example, for iPhone 15, I don't have data for that because it's just going to be made next year. So I'm going to ask a group of people that what do they think about the demand for that product in the future. So that is called the qualitative models. And Delphi method is the most famous one. I have explained the procedure for that here, and I have made a video for that as well. Please have a look at the videos uploaded under the Moodle page of this course. I think that's it. Just one last comment. If you have not defined the topic for your course project, please send me an email as soon as possible. Please send me your top 3 priorities because most of the projects are taken. So I can move from if the first project that is your priority is taken, I can move to the second and then move to the third if they are taken. So that's the first announcement. The next announcement is March 1st, which is the first week after the study break. Will be your midterm. Please study hard. Please spend a lot of time for this chapter because this is a new chapter for you. This is numerical. I have uploaded some examples and solutions under the Moodle page. Please practice them to get ready. I will issue an announcement about the details of the exam. And next week is a study break. So there is no class. Just use it for your course assignment, course project, and also midterm. Okay. Thank you very much, everyone. If you have any question, you are more than welcome to ask. Otherwise, you can leave the session. Any questions?
Thank you, Professor. See you.
Thank you.